Okay, so one final example. National survey of Virginia drivers showed that 80% found traffic conditions to be unsatisfactory on I-95. Then they took a sample of 400 Virginia drivers and they felt if the driving conditions on I-95 were unsatisfactory. Find the mean and standard deviation, and then find a couple probabilities. Again, I was hoping that you would work this through prior to looking through the solutions to this. Okay, so if you didn't, please pause it, go back and work through it. Okay, when I do this, the first thing I notice is that the probability of success P is 80% or 0.80. Okay, so we're going to use that. Also find that Q is 1 minus 0.80 or 0.20. And then the sample size is 400. Okay, so again, you have to have those items before you go through and try to do the rest of it. For A, mu sub P is equal to P, which is equal to 0.80. Okay, so that's the mean of the 400 drivers. The standard deviation, sigma sub P, is going to be equal to the PQ over N square root. So remember, that's our formula. P times Q divided by N. I'll just continue it down here. That's going to be equal to the square root of 0.80 times 0.20, and then we're going to divide all of that by 400. Right. I'm going to go through. I'm just going to throw this into the calculator. Again, you should probably do this just to make sure that you're doing it that you can do it as well. And I wound up with exactly 0.02. Okay, so we're going to hold on to both of those. So we have 0.80 and 0.02. For part B, find the probability that between, okay, so this is a Z1 and Z2, between 300 and 315 of the 400 found driving conditions to be unsatisfactory. All right, so we're going to have two x's in this case. The first x, I'm going to call x1, is going to be the bigger number, 315, divided by the sample size 400. Remember, x has to be a proportion or a percentage. In my calculator, that's 0.7875. Okay. X2, 300 out of 400, 3/4, 0.75. If we draw this on a distribution, just to see what it looks like, in the middle is 0.80. All right, so that's the mean. 7875 shouldn't be too far away. 75.75, that's probably pretty far away. Right, so we're looking at this area in between. All right, I don't know what that works out to be. If we could guess 10, 20, or 30%, that would probably be a good guess. Okay, we're going to find two z-scores now. Okay, so z sub 1, that's going to be equal to the bigger x, so that's going to be 0.7875 minus 0.80, which is the mean. We're going to divide that by 0.02. Okay. I got negative 0.63. And then I'm going to convert this into a z-score using our z-table. $26.43 is what I get. Okay, so we're going to hold on to that number. And we also have to figure out z2 for our smaller x. So z sub 2 is going to be equal to 0.75 minus 0.8 divided by 0.02. Okay. I'm pretty sure this is negative 5/2, which should be negative 2.5, but I'll just verify it. Negative 2.50. Now that's the z-score. Again, we're going to convert that using our z-table into an area. Negative 2.50, I got 0.0062. Finally, to find the area, we are going to take the area between, we're going to take both the area from Z1, we're going to divide or subtract that by 0.062, which is the area from Z2. So the total area is going to be 0.2643 minus 0.0062. That's a 0 in English. All right. If we do that, 2581, I think. I'm going to write it there. I'm going to verify it using my calculator. 2581. All right. That's our final solution. All right. Finally, we're asked to determine the probability that more than 350 out of 400 find the driving conditions to be unsatisfactory. So, just like we did in the previous problem, we have a more than. So x is going to be 350 divided by 400. So 350 divided 400 is 0.875. On our graph, 0.875 is pretty far away from the mean of 0.80. So we have our mean 0.80. 0.875 is way over here. It's a more than problem. So that's what we're looking at. We're going to find our z-score. Z is going to be 0.875 minus 0.80 divided by 0.02. I wound up with 3.75. We're going to convert that using our z-table. It's going to be a pretty big one. It should be 9999, but I'll just verify by looking at it in the z-table. So 3.75, 9999. And of course, since it's a more than problem, every time you're looking at this, you're going to take the complement. So for our final answer, that's 1 minus 9999, which is 0.0001. All right. In your calculator, it might have something like 1e to the minus 3. So, or 1e to the minus 4. So let me just show you what happens if that does occur. And so let's say for some reason, out there. Let's go down here. That's fine. I'll just do it up here. Just give it some space. So let's say for some reason that you encounter a solution in your calculator like this. So 1e minus 4. All right? That's what I got when I typed it into my calculator. That's scientific notation. That's the same thing as 1 times 10 to the minus 4th power. And what you would do is you take the 1, which has a decimal point here, and since you have a negative 4, that means you're going to move the decimal point 1, 2, 3, 4 places to the left. And you're just going to fill in those loops with zeros. Okay, so if you do intend to use your calculator for that computation, just be leery of the fact that you might end up with getting scientific notation. All you have to do is just bump the decimal point to the left if the e is negative, or if the value after e is negative, and then to the right if the value after e is positive.